All businesses ultimately use data science for just one reason: to solve real business problems, to find valuable information needles in a very large data haystacks. So at its core, data science is all about problem solving. And because of this, if you want to be a better data scientist, one place to start is becoming a better thinker and problem solver, rather than spending time debating whether you should learn Python or R first. In this video, I will share with you a formula or a framework to solve a problem. So that's a formula that can be applied universally. I will also demonstrate how this framework works with a big analytics project. So now let's get started. The framework goes like this. So step number 1, we understand the big or general business problem at hand. Here, we thoroughly examine what the problem is and what led to the problem in the first place. And then step number 2, we break the big problem down into multiple bite-sized components. So in the analytics world, it's also called segmentation, which we will be discussing later. Moving on to step number 3, we translate each component identified into analytics. And now we have a plan, and next step is to execute to make the plan work. Next up, let's see how this framework can be applied to solve a big analytics project. Let's say you're a data scientist working in an insurance company, and your company issues millions of dollars in claims overpayments every single year. Here, a little background. What is a claim overpayment? Well, when you go to see your doctor and he or she performs some checkup for you and then submits a claim on behalf of you to your insurance company to get paid for this service, and let's see it's $200. And then for whatever reason, he or she gets a payment of $500 from your insurance company. And that $300 is an overpayment because it exceeds the amount payable for the service rendered. As we can see, overpayments not only hurt the bottom line of your company's financials, it also may result in complaints and dissatisfaction from healthcare providers. Given these, your company plans to launch a project to reduce claims overpayments. And this is a typical problem for data science, which often is stated vaguely and broadly. First step, understand the business problem. And here I use this 4 quads paradigm to help with my thought process. So first we have the business challenge quad, where we define the problem. So for our example, we have $20 million in overpayments annually, and it's causing various issues. Then comes the business request. Simple, the company wants to reduce overpayments. Next, what are the obstacles in solving this problem, right? Like how to find the root causes, how to translate each into analytics and prioritize and so on. And last, let's hold off on the analytics solution part and we will fill it in later. After the business goal is clear, we move on to step number 2, break the problem down into various small components. So for analytics projects, we have historical data. So this step is often referred to as data segmentation based on past activity. In a nutshell, we provide descriptive answers to the question, what happened? So for example, we explore the overpayment results to find possible root causes or contributing factors. At this stage, as a data scientist, you will focus on qualitative analysis, meaning you will most likely collaborate with business partners to identify potential contributing factors. And also, you will perform a quantitative analysis, like summary level statistics and visualizations, to explore your historical data and also to attach a dollar value to each factor. Now, going back to our claims overpayment project, analyzing historical data, you're able to segment out the following contributing factors. So first, we overpay because claim adjusters don't have enough training, or they are so overloaded with work that they can't correctly handle those files. And the second source of overpayment is claims fraud. So for example, a healthcare provider may have submitted services that are not covered by the patient's insurance plan. And third, claims overpayment also comes from insufficient overpayment recovery. Because there is overpayment happening, your company must already have a recovery process set in place to get the money back. However, this process might be too old to function properly, which results in an extended recovery time. In the real-world insurance industry, there will be way more contributing factors. But here, for simplicity, we will focus on these small components to look into in order to tackle this problem. Now let's see how we can translate each piece into analytics activities. So here on the screen shows each contributing factor and its corresponding analytics activities. For example, the claims adjuster's work overload can be translated into an analytics project of better claims triage. And that is, we design a machine learning model to automatically assign adjusters to claims to process based on their expertise. So for example, assign high-cost claims to adjusters with more years of experience. And then claims fraud can be translated into an analytics project to identify potential fraudulent claims when they first come in. Insufficient overpayment recovery, again, can be solved by building an automated system to track and monitor the recovery process. Having this list in your back pocket, in the ideal world, we would want to tackle all the contributing factors, right? But in real business world, we can't boil the ocean, meaning that we have to select and set priority. But how to set priority, you may ask, right? Well, the simplest way is which component brings the largest financial benefits. To get an idea of the financial impact, we ask the what if question, or we do the what if analysis. So for example, what if we fix the issue of claims fraud? How much overpayments we could reduce? And that is based on the historical data, how much money is attributable to claims fraud. So we do the same analysis for all the three factors. At this step, the best way is to use visualizations to show the segmented values. So for example, we could use a pie chart for percentages of financial dollars. Clearly, claims fraud is the biggest root cause of overpayments in terms of financial impact, meaning if we could fix this issue, we would be able to reduce the overpayments by 60%. And now you can present your preliminary analysis to the executives and propose to set the priority of this big overpayment project to a much smaller project of identifying claims fraud. With this plan in place, next up we execute. And that is, we use analytics to identify the potential fraud claims to reduce overpayments. How should we go about it? And again, segmentation or divide and conquer. Basically, there are two ways to achieve this goal. The first one is business rule-based approach. For example, based on contract, claims submitted after 3 months cannot be processed. So we are not supposed to pay for the claims if they are not submitted timely. Or the procedures or surgery is not covered under this plan, or the claim is billed under a healthcare provider with a completely different expertise, like FSAN claims for treating prostate disease billed under an OBGYN doctor. Another approach is to build a predictive model to identify potential fraud. And this problem can also be solved using the same framework. If you'd like to, feel free to pause here for a minute and think about how you would fit this problem into the framework we've been discussing. Now we can revisit our 4 quads and fill in the last one with our analytics solutions, and that is focus on claims fraud, which accounts for 60% of overpayment in terms of financial impact. We develop business-based rules and also build predictive algorithm to predict which claim is potentially fraudulent. Now you've learned this framework, and all you need to do is to practice until it becomes a natural thought process for you. So thank you so much for watching. I hope you find this video useful and inspiring. So don't forget to like and subscribe. Until next time, bye guys.